Hello there, random smart person on the internet. The two most powerful and famous space telescopes ever built, the James Webb Space Telescope and the Hubble Space Telescope, became famous with photos like these. Even though they are famous for their deep sky observations, they also collect data on objects that are in our own backyard, relatively speaking. Both telescopes are collecting data on the most volcanically active body in our entire solar system, Jupiter's closest Galilean moon, Io. This data will be used in combination with upcoming flybys of Io by NASA's Juno spacecraft, which is currently surveying the Jupiter system and is slated to conduct these flybys towards the end of 2023 and early 2024. The purpose of examining this small volcanic moon with these two powerful telescopes and one orbiting spacecraft is for scientists to gain a better understanding of how Io's escaping atmosphere interacts with Jupiter's surrounding magnetic and plasma environment. The timing of this project is critical. Over the next year, Juno will fly by Io several times, offering rare opportunities to observe the moon-planet system. Scientists hope to gain a new insight into Io's dramatic volcanism, plasma-moon interactions, and the neutral gas and plasma populations that run through Jupiter's magnetosphere and trigger Jupiter's beautiful aurora emissions. Requesting observing time on Hubble is done through NASA's Hubble Space Telescope Observing Program, and is allocated based on the number of orbits that Hubble will be asked to complete around Earth for each science campaign to complete its research, with each orbit taking approximately 90 minutes. Typically, large observing projects request 75 or more orbits. This is not the first time that Hubble has examined Jupiter, and it has an extensive history of studying the largest planet in the solar system. For this campaign, scientists will be using 122 orbits of Hubble around the Earth to gather data on Io for a total time of 183 observing hours, or just over 4¼ complete orbits of Io around Jupiter, with each orbit taking approximately 42½ hours. For comparison, our moon takes a total of 27 days to make one orbit. Additionally, James Webb Space Telescope will gather data on Io for just under 5 hours. Jupiter's massive magnetic field is comprised of a giant bubble of charged particles that encircles and swirls around the largest planet in the solar system, of which is comprised mostly of Io's escaping atmosphere. Scientists are hoping to learn more about multiple topics, including the interaction of Io's atmosphere, surface volatiles, volcanic eruptions, Io's extended neutral cloud, Jupiter's ionosphere, and the Io plasma torus. Most of these materials don't actually escape straight out of the volcanoes, but rather are associated with the sublimation of sulfur dioxide frost from Io's dayside surface. The interaction between Io's atmosphere and the surrounding plasma provides the escape mechanism for gases released from the moon's frozen surface. After arriving at Jupiter in July of 2016, Juno spent its primary science mission studying Jupiter, including its interior, aurorae, and massive magnetosphere. Juno's extended mission began in August of 2021, which is slated to last until September 2025, and has been used to conduct flybys of Jupiter's Galilean moons Io, Europa, Ganymede, and Callisto. For Io, Juno has already conducted flybys in 2022 and in early 2023, with close flybys being scheduled for December 30th, 2023, February 1st, 2024, and September 20th, 2024. Io is the most volcanically active body in the entire solar system, boasting hundreds of volcanoes that discharge lava dozens of miles into space. Its volcanic activity is a result of tidal heating, as the small moon is compressed and stretched by the much more massive Jupiter, along with its two outer moons, Europa and Ganymede. Io's volcanic activity was first predicted just prior to the arrival of NASA's Voyager 1 in 1979, which confirmed this activity and imaged the first signs of active volcanism outside of Earth. So there you have it. You learned how Hubble and James Webb are conducting scientific research in our own solar system. Leave a comment down below on which is your favorite space telescope image and why. Comments are good for the YouTube algorithm. If you would like to learn more about the European Space Agency's mission to Jupiter, click on the video right here. Or, if you'd like to learn more about how we're able to see objects 46 billion light years away in a universe that is only 13.8 billion years old, click on the video right here. And always remember, have fun with STEM.